Hi, today I just want to show you how quickly and fast is to calculate subnets by using this table right here. It's a very simple table. It's a table that you can learn, so simple to learn, and you just have to learn some things to know how to use it in order to calculate some subnets, or whenever you have to do VLSM also works. So basically, this table is going to be very helpful if you want to basically study subnetting or calculate subnets. Now, the thing that you need to know is, uh, as you know, uh, every single IP address is composed by 32 bits, right? So remember that it's gonna be 4 octets. So it will be like this. All right. So remember, if the prefix is an 18, for example, this network right here is gonna change. Right, so far right here 16, 17, 18. So it will be right here. So we'll be changing in the third one, the octet number 3 right here. So this one is the one that is going to move and change if we are using 18, prefix 18. If we are using 24, right here is 16, right here is 24, so it will be changing right here in the last one. So this one is going to change. But right now, so far, we're using 18, and I'm going to show you how easy it is to calculate this. Also remember, every time that you are in 256, you have to start all over again. And when I say start all over again, is like, as you can see right here, is 2, 4, 8, 16, 32, 64, 128, and 256. So when you get right here, we have over here in this part the host, the amount of hosts that you can use. However, an easy way to calculate this is start all over again in the after the or below 24 starts all over again. So right here we start from 2. So right here is 1, 2, 4, 8, 16, 32, 64, 128, and 256. Right here we start all over again. 2, 4, 8, 16, 32, 64, 128, and 256. So you have to start all over again from 24 right here, and from here. So let me show you how easy it is to calculate without doing ones and zeros. Most of the people, they cannot understand when the teacher is basically explaining something with zeros and ones, because they got there is a lot of confusion at the end, or they're going maybe too fast, or whatever reason it is, they cannot understand. This way is very simple. Now we have this network right here, 172.19.0.0, right? So remember, with the rule that I said, right here is gonna be, okay, so we are 2, 4, 8, 16, 32, and 64, right? So it's gonna be hops of 64. There are gonna be hops of 64 for this network right here for 18 prefix. So the first usable is going to be this one, right? And since the hops are 64, we cannot use 64 because that's our next hop. So we're going to use 63. This is the last one, and the broadcast is 63255. Now we're gonna see if this is right or wrong. I already have right here. We have the 00. Let me put right here 00. Okay, here it is. It says first one is 01, and I have right here the 01. The last one is 63254. Right here is 63254. And the last one is 63255 right here. Okay. All right. And the next, okay, let me fix this right here. Okay. Next hop is 64, right? Still 18. We are not doing VLSM. Yeah, we're just calculating some subnets right here that we can basically have with 18 prefix. Okay, so 172.19 right here is 64.1. 172.19. Remember, it hops is 64 plus 64 is 128. That's 64 plus 64 is 128. So we're not going to use 128. We're going to use 127. Okay. And this is the last one. So let's see if this is right or wrong. 64. 64.1 is the first one. 127 is 254 is the last one. 127 255 is the broadcast. Next is gonna be 128, right? Okay. 72, 19, 120, 28. 128 plus 64 is 192. Wait, we have to put right here 1, which is the first one, then 191, 54, 172, 19, 91, 255, right? Okay, next hop. 192. Right here is 91, sorry guys. This one is the next one under 18. Okay, so you can basically continue on and on according to this prefix 18. So if you come right here and you say, okay, what is a subnet mask? It's very simple. You just learned that there is two ways. You can just see it right here. It is the 255.255.192.0, or you can do this. You already know it's 64 hops, right? And 18. So 256 minus 64 is 192. Now 192 is right here. You see that? And why in the third one? Because, as I said earlier, this is changing right here. 18 is over here. Therefore, is the third one. Okay? It's going to be basically the same if you are using greater prefixes or lower prefixes. If you're using 25, 26, 27, 28, it's going to be exactly the same. You just have to make sure you're changing in the last one. Right here in class C is changing in the third one. Class B is changing right here in the second one. And class A is changing in the first one, right? And also remember always the rule that whenever you get to 256, you have to start all over from 2, 4, 8, 16, 32, the hops, right? I'm going to show you now if they ask you some questions like, for example, if they tell you, if you're in a company and they tell you, I need 4,000 hosts, so, and they give you, for example, this address. Okay, we're gonna do VLSM right now. All right, and they say, okay, so I need 4,000 hosts. Okay, so first thing that you need to do is make sure in the table that I'm showing right here, you look for 4,000 or nearly 4,000. 2,000 doesn't work. 4,000 works, right? Right here, 4,096 is gonna work. So you already know that 419 is 8,000, but they are not asking for 8,000. They are asking for 4,000 right here. So you already know that its prefix is 20. So you have to change that first. 20, right? It is right here. And now, next thing that you want to do is how many, or how many hops are gonna be for the next, address. So we apply the rule that I was saying earlier. Right here is 0 or 1, 2, 4, 8, 16, right? 16 hops. And it's gonna change over here in the third one, right? Because right here so far we have 16, now 17, 18, 19, 20, right? Right here in this octet right here. Okay, so 172, 19, 224, 1 is the first one, if I'm not mistaken. 172, 19, the next 224 plus 16 is 240, but we're not going to use 240. We're going to use 239. 254, 72, 19, 239, that 255. Next hop is going to be 240. And this is going to be 0. And now we can continue. So there is right here 4,000 hosts, and with 21 we will have 2,000 hosts. Okay, and let's say that they ask you for 2,000 hosts now. Okay, all right, now is 21. 21 is hops off. Let's do it again right here. 0 or 1, 2, 4, 8, 16. So right here is 8 hops. So 172, 19, 240. Well, the first one is 1, so 219, 248, so 247. 254, 172, 240, 247, 254. Okay, next hop is going to be 248, 0, 22. Now this mask for 4,000 was 255, 255. Okay, that was 20. 240, 0, and for 2,000 is 255, 255, 248, 0, and for 22 prefix is basically able to support 22 is able to support 1000 hosts. Still changing in the third octet. I'm having a hard time pronouncing that word, so I'll just say it's basically changing right here. Okay, so right here is gonna be hops of, okay, so we have 0, 2, 4, right? 4. So 248. And next one is gonna be, let me double check, 248 1. Next hop is 52, 251. 251, 255, 252, 0, and so on. You can continue right here for, okay, next one is, for example, 500 to, and then 256, and so on. Just remember, when you get right here, it's going to change in the last octet. It's not going to change in the third one. Right here are the masks according to the prefix that you're using. Okay, now I have some examples right here. Let me, okay, what happens if they tell you I need, for example, right here it says number of subnets 14, number of hosts 14. All right, so subnets 14. So you come right here, and this part of the this part right here, the one that says classes, okay, you look for 14. There is no 14, only 16, right? However, this is gonna work, and you already know it's 240. However, not in class B, but in class C, because they are telling you this is a class C network. They're telling you it's a class C network. So in class C, which subnet mask has 240? This one right here. Okay. All right, and also they're telling you 14 hosts. 14 hosts. Okay, so they need 14, not only 14 subnets, which we already used the table to calculate the subnet mask by, there is no 14, so we use 16, and we already know it's 240. All right, right here in class C is 240, but they are, how many hosts can you basically support with this mask? 4096. That's a lot, and they are asking only for 14 hosts. So what you're gonna do now, look for the host maximum of hosts that they are asking you is 14. You come right here 16, and now you're gonna notice is 255 to 255 to 255, that's 40. That's the subnet mask used for this exercise. It is right here. Let's try another one. It says subnets needed for this example are 1000. So you come right here and you see 1000. Okay, here it is. And that's 255 to 192. That's 192. Then they are asking you for 60 hosts. So you come to the hosts. 60 is right here. 64 is the maximum. 60 is not right here, but anyways, 64 is the one that we're gonna use. And what is the subnet mask is 192 right here. You see? 192. 192. It's as simple as that. And also you can calculate the wildcard by using the same exact table. How are you going to do that? Well, the 255s are going to be zeros. All right. Let me give you an example so we can just let's go to let me just erase this. 172 16 19 0 0. Okay, so for 18, which is right here, the subnet mask is 192.0. This one. Okay. Okay, so how many hops do you need for 18? Let's count again. Right here it was 1, 2, 4, 8, 16, 32, 64, right? So the wildcard for this, remember 255s are going to be 0 in order to calculate the wildcard. 0, that's 0, and 64 hops, right? It's going to be actually 63. Is the number of hops minus 1. 63, that 255. Zeros are going to be at the end 255s. Okay? This is a wildcard for this network right here. I'm going to do some more examples. In order to see if this is right or wrong, we're going to put right here so you can see I'm not basically wrong. The wildcard was 0 0 63 255. 0 0 63 255. Okay? Now, here's another example, maybe with 20. Alright? What is the 20 subnet mask? 20 subnet mask is 240. Right here, look. 240. Let me see if this is a recording. It is. Okay, 240, right? It's this one right here. 255, 255, 240, 0. Now remember, 255s are going to be 0. So 0, 0. And now 240 needs to change for the wildcard. How many hops are there for 20? Let's count. 0, 2, 4, 8, 16, right? We're not going to use 16. Remember, 16 is the hop, or the number of hops. 16 minus 1 is 15. And 255. Let's see if this is right. 20 right here. 15 255. There it is. And I'm not doing ones and zeros like most of other guys basically use to do in order to calculate these kind of things. For me, this is simple, more simple than doing ones and zeros, and it's just a matter of learning how this table works in order to see how many, as I said before, if they are asking you for 1000, you just locate the 1000 right here. You see it's 192. Then they're asking you for 60 hosts, and we saw that was 64. So this is the new subnet mask that this question that this question was asking. As you can see, it's very simple. I will see if I can put this in the description below this table, but I hope you enjoy this video.